So let's please all welcome Dean Leo Kempel.
Thank you so much, Jeff. And thank you so much for inviting me here. It's always gratifying to come back to your home. I left here 30 years ago, but Ann Arbor has always been home for me. There's a few things about this. One thing is the alumni distinguished, what was the award name?
Educator award.
Okay, so, right, so Shanker, who a few of you know, would dispute the distinguished part, certainly, and would dispute the educator part, certainly, as you'll see. The alumni is true. The alumni is true. So yeah, I am the Dennis P. Nyquist Endowed Professor, and why that matters in this talk is the reason I'm at MSU is Tom Sr. So back in the day, 1998, the department was looking at MSU was looking to replace Kung-Wu Chen, who was going to retire. He had been here at the Rad Lab and then brought to East Lansing to start a program back when MSU was moving from, this is being recorded, so I'm going to be careful. I've got 12 days, I have to be a good boy. To start a program that's more research intensive, let me put it that way. Kung-Wu moved from Ann Arbor to East Lansing and started a group. Dennis was his first student. And when came time to replace him, they picked me because our height was the same. So obviously you had to conserve height. And so the reason I'm there is because Tom Sr. sent a note to Dennis. Okay, and that's kind of where this all came from. So I'm very pleased to have his name as part of my appointment. And Shanker was the one who got it for me. He was the co-conspirator on that. So, okay, I figured out. So here's my journey. I asked Eric, what am I supposed to talk about? Because I'm used to giving two kinds of talks. I'm used to giving one talk where it's technical and we dive down into weeds and I try to explain why you should pay us to do this work. Tony, you're familiar with that one, right? And the other one is I'm used to giving talks where I'm asking people for money to build buildings or to endow faculty positions or whatever. Karen, you're gonna get very familiar with that one. I'm not used to talking about teaching, right? And kind of my journey on that is a little funny because I didn't teach for a long time. So I went to Cincinnati. I'm first gen. I had no clue what I was doing. I went to Cincinnati because it's a state institution in Ohio where I was born, farthest away from where I grew up. And I figured that way mom won't be showing up on a Friday night just to see how things are going. Okay, but it did have a great program where you had to co-op. It was a 5-year program. And so I was having a great time as a student, as a frat member. Enough said about that, okay? And then I think maybe third assignment in co-op was really fun. I mean, it's one of those times when you can't believe someone's paying you to do that. Well, I needed the money, so I was glad they paid me. But it was a great time. And I looked around, they all had masters and PhDs. Okay, you better start taking this more seriously. So by the way, if you look at my grades, they went like that, okay? And the reason I'm so thankful at Michigan coming here is because at that time, at least, you went through and recalculated your grade point average based on the last 2 years, which was distinctly better than the whole time. And so I came here and had a great time, fantastic time with the leaders and best. I mean, grad school, if you're a grad student, it's the best time, by far. It's the last time in your life you get to do one thing and really concentrate on. From now on, you won't get to do that. So then I asked Tom Sr. what I should do, because I had offers, right? And he says, you should go to a company and build a Rolodex so you know who to call to get funding from if you ever decide to be a faculty member. So that's exactly what I did. I went to Mission Research Corporation and learned how to get money, because the difference between academia and a company like that is you have to get funding in or you're out of a job, right? There is no tenure, there is no anything, there's no classes to teach, right? And so you learn very quickly how to do that. So that's a great skill as a faculty member. For anyone who wants to be a faculty member, that's important. Right, Eric? That's a fairly important thing to be able to do. So then I went up to MSU, did the normal stuff, assistant, associate professor. I spent some time with the Air Force, started the High Performance Computing Center. That was fun. That all had to do, by the way, with our building of an accelerator on campus. And we wanted to be honest with you, show that we had that club in the golf bag, comparing ourselves with some of the DOE labs. Then special initiatives, man, that was fun. That was like, you had no responsibility, none at all. Okay, I just became Satish's, guy to go out and fix things. And then research, which is the best job. Being the associate dean for research was awesome. And then my friend left me to go to do other things, and I became dean. So what's next? Have fun. Okay, so I'm going to now go into a few things just to talk about our college, because if nothing else, the slides I got made for me by our PR people, so I need to show that a little bit. Here's a snapshot of our college. What's important is the number of students has gone up by about 50 to 60% over the last 10 years. I know you're experiencing some of that also. The big growth in computer science, and I'll show data, and it shows it to you, but that's really where it goes. We've had a lot of progress towards inclusivity. These are percentages, and it kind of hides something. The percentage of women's been roughly constant, but the number of students has gone up by 50%. So we have a lot more women students in our college than we did when I first started in 2013. But you notice the number of the percentage of underrepresented students have dramatically gone up. Okay, and what I'm going to talk a little bit about here is how you convert interests of students into students who stay and students who leave with the degree, and I'll talk a bit about that. So here's a quick snapshot. We got 12 bachelors. There's 2 new ones I'll talk briefly about. 11 grad degrees. They're all the normal ones you're used to seeing. But the number of faculty has really gone up. When I started, that number was 167. And so over the period of time, we've been able to grow the faculty a lot. We didn't necessarily grow the space as fast. That's absolutely true. So you've got to balance space-intensive hires with non-space-intensive hires, because that's the business that we're in. And the faculty are doing well. This is a snapshot from a year where young faculty are getting career awards of various types. That's as NSF. The real thing is NSF, OSR, all the different ones are really lumped. 8 fellows. These are different professorships that we have available. So, I mean, things are going reasonably well on that. Here's the degree programs. I'll spend a moment on this. You notice there's 2 in light green, okay? Computational data science. Now, when this came about, to be really blunt, we looked here to Ann Arbor to see how you all did it. And what I could tell, and I may be wrong, but LS&A wanted data science and engineering wanted data science. Therefore, you both have it. That sound about right? College of Natural Science wanted data science. Engineering wanted data science. So we both created one. So if you want data science, there's 2 ways of doing it. I will tell you that our push on this one will be to get, you notice that there's no little dot next to the check. The dot means it's ABET accredited. So that's going to be the thing that Giannis pushes, the next dean, is to push them towards ABET accreditation as a distinction going forward. Because I don't think the Science College will do that, because none of their programs have an accreditation like that. So then the other one that's new is technology engineering. That's brand new, just started this term. And what this is in the simplest way I can describe it, is if you look at the ECE curriculum, it's about 70% theory when you take it all together, and about 30% lab. This flips it. And the reason for that is We need more people. And when you look at the data from the department here, and you look at the data from East Lansing, and if you include Michigan Tech, and I've got data, Karen, I sent this to you, so you have all that data now. Those three are over half the total ECE students in the state at the bachelor's level at any given time. And so if these schools aren't growing them, they're not going to grow. That's a simple fact. And so we started this program in order to expand an engineering career to more students who can't follow that path at this point. And it's meant to be different. It's meant to be very different, much more hands-on. So when you start looking at people who are going to go into the factories, there's probably going to be more people from this program. If you look for people who are going to be field engineers who go out and help in installations and so forth, it's probably going to be people in that program. Less so the EEs and computer engineers and so forth. But what's the prospect like? This is from the U.S. Bureau of Labor Statistics, and you can do it for any program you have, because the numbers are more or less the same. We are living in a great time to be in an engineering program. Enjoy it now. It will change. It always changes, right, Val? You get ups, you go downs. You get ups, you get downs. So right now, the pay, and I'll show some data in a minute, is near the top for the graduates of these programs. But the thing to really look at is this 9% factor, that the need is growing faster than the supply. Okay, the need is growing faster than supply, and that's true here in Michigan. We have some of the largest concentration of engineers per capita in the country, yet we still have a deficit in the number of electrical and computer and engineering students in particular. We do have a lot of mechanical engineering students. We've got an awful lot of computer science students. But for some reason, ECE hasn't been the magnet that the state needs. The state works with Eric and myself and a few others on that. And this kind of shows it to you. This is a snapshot of the incoming student interest at MSU from 2014 to 2023. And what you see is, the first thing, chemical and engineering is way down. The reason for that, by the way, is the generation we're in now doesn't necessarily want to work for energy companies. And if you get a chemical engineering degree, where do you go work? Someone told me they were in Findlay recently, right? Marathon hires a bunch of our grads. So, but something that really jumps out is mechanical has always been high here in the state. Probably always will be. Computer science. That's what's happened in the last 10 years in terms of that growth of student interest. Now, this is students coming in. They don't necessarily finish in these programs, but this is where they come in thinking that they want. Notice computer engineering, flat and low. Electrical engineering, flat and low. Those numbers have not gone up. We haven't got the message out that the best jobs are going to be in these programs. Okay, now of course we'll blame the department chair on that, obviously. Of course that's who you should blame. But it's pointing out the fact that the natural supply approach isn't working. That's why the state started the Michigan Scholars Program that we're part of, because we wanted to incentivize students to choose programs relevant to the electric vehicle industry and relevant to semiconductors in particular. So if you don't know what that program is, if you're in the program and you intern at one of the companies, you get a $5,000 scholarship from this state, above and beyond anything else that you have. And if you take full-time employment with one of those companies afterwards, they give you another $5,000. So it was a blatant approach that's being followed to try to incentivize people to maybe push some of this down and some of this up, because that's where the need is. So that's one approach. And to some extent, things are good, because if you look at our data on juniors and seniors, you'll notice that we're roughly speaking, we're graduating about 200 more students from the college in East Lansing a year than we did before. but they're not in electrical engineering. They're not in computer engineering. They're up a little bit, but not at the numbers needed. So the point I'm getting at is as part of the two big institutions in the state, how are we going to grow the workforce to build the economy here? We have to be building the workforce based on need. And the past system of students choosing what they want to is not going to meet that need. And as I said, if you look at data, the big kahunas in the room are going to be here in Ann Arbor and in East Lansing. But it's not just attracting students. It went the wrong way. You got to make sure they succeed. And I know there's a lot of programs here in Ann Arbor. My daughter Hannah finished here, I think 2020 and 21 in EE. Okay, she had her own built-in tutor for the senior project, where they would Zoom me to get advice on how to do their project. And by the way, the ground plane was too small. Right? If I showed it to anyone from the rad lab, the first thing you'd say is your ground plane's too small. Okay, fine. Let's see if I go the right way this time. So this is the pay. This is straight off of the college scorecard. Now, if you've never seen that, in 2016, the US government required universities to start reporting outcome data by program, not as one composite across the whole university. So before that, if I showed you data, it would have been an average of your students finishing and pick another North Campus art history finishing. I think there might be a little difference in compensation there. So 2016, the requirement was you have to start reporting all. And if you know how to play with it, you can find this kind of stuff, which I did for MSU. And I highlighted the two programs that come from this department, and you're in the top 5. This is what you can expect to earn with a degree in that program. I think this was set at 10 years after you finish, right? So 10 years after you finish, the number 1, by the way, is computer science. There's a reason for that. Where do your computer science students go when they finish? We talked about this, right? You go out of state, probably to California. Salaries might be a little bit larger in San Francisco than even Ann Arbor, okay? And so that kind of pushes that up. A lot of these students stay in the Midwest. And so the compensation is quite good. By the way, the only one in the top 5 from my university that's not from our college is this one here, construction engineering. For historical reasons, it's in the College of Agriculture and Social Science. Now, the reason is, well, construction, you use wood. And where's forestry? I'm not kidding. By the way, School of Packaging that you may have heard of, it's in ag, okay? Because pallets were made with wood. Therefore, you put it down. So our degrees are the ones that pay. And so that, I believe, has been pushing those numbers up because people look at it in-state with room and board and in-state tuition, you're going to pay well north of $100,000 to finish a 4-year degree here. Well north of that. It's more here. I paid those bills. I notice there's a little difference between the second year and the third year. A little bit difference. So, but a lot of the programs, the compensation isn't there. And it's going to get worse over time. So I think the student interest will keep pushing up. What we have to do is keep them. And keep them here in the Midwest, because I'm not here to grow the economy in California. I'm not here to grow the economy in Texas. This is, by the way, where a lot of those chemical engineers end up going. Great place for fundraising, Karen. When you're going to go chemi, you go to Texas. Yeah, you got to get boots, a belt, hat. You're all set. You're all set, right? Right. So, but the Midwest is where we live here, and the difference between Ann Arbor and East Lansing is where the students come from. 70% of our incoming class comes from Michigan. Yours is less. We can argue on how much less, and people tend to go back to where they come from often. And so we want to keep placing students here. This number, 59%, is way down from before because of computer science. I can track it. As computer science numbers went up, the percentage staying in the Midwest went down. So I think that we need to help build the computer science industry here in Michigan to hold that talent back. It's not going to happen by itself. And we got to get students involved. So here's the very mandatory: when you have a donor who gives you a chunk of money to do something you want, you put their name on it and you put it in your presentation so you can talk about how you discussed all this with your friends in Ann Arbor. Okay? And so these are very student groups. You have the same thing here. We basically stole the idea with a nicer building, okay? Because it's new, right? I will tell you that there's a reason for this. The facility we had before was off campus. It had not grown as the college grew, so it was getting tight. It was across the street from the high school for the town there. That just didn't work well for me. I could see all kinds of liability issues that could pop up on that. So now it's on campus. It's where you can get to with parking and buses and all that, and the students are building things. The most recent is the autonomous auto challenge recently. The team we're on took first place in one category and second place in speed. So now we're talking about that more and more because you took first, because a gold medal and a silver medal. So, but this is the thing that I really want to talk about, the part of keeping people who have interest, and you got to help them. And our signature program, we've called it ESSA forever. What it stood for has changed over time. As funding comes and goes, as different structures come and go, we change it, but we always kept it as ESSA. Currently, it's called the Engineering and Science Success Academy. Don't read all that, it's lots of words. It's very simple. When you come to MSU and you put your deposit down, the next thing you do is you take a math placement test. All students do. And it places you in your first math course. The data we have is the single biggest indicator whether you're going to graduate with an engineering degree is what the first math course is you were placed in. If you were placed in Calc 1, the traditional entry point, you had a, say, 60% chance of completing. And now some of those people move. I found out a number of them come here, by the way. They start their first year in East Lansing, and then they transfer down here. But if you start one course down, it drops to 30%. And if you drop one course down from that, which in a practical sense is as low as you can get and finish within the college in time, it drops to 15%. And so what can we do to help them when you come from rural Michigan or you come from an urban part where you didn't have all the advantages you get here in Ann Arbor or East Lansing or Okemos or any of those areas? We started this. And so what we do is when we see someone who has an interest in engineering from a high school that historically has had challenges in placing people in the college, and we look at their math placement, we invite them up to campus for part of the summer. And we pay their housing, we pay for the instructors and all that. It's very expensive. This is a very expensive program. It's hard to scale to large numbers. But I'll show you data that it works. And so they come in and it's math boot camp. And depending on what major they want, they'll do some chemistry or some physics too, to try to bridge that as well. And bio, I think bio is one of them. But they also get used to campus because almost all these students are first gen. They have no context for how to move around a campus or how to do things or whatnot. So you want to get people introduce them to people who've been in the program before, so they're mentors, and get them used to the campus environment before the big flood in August. Okay? So does it work? And the answer is yes, it works. So All the students now in our program have engineering as a target. The LSAMP program, which I know we're partners with on, and I think Western maybe, has something that also handles physics and chemistry and biology and so forth. So this program now is just for us. The composition of students by gender is about the same as the college, roughly. And none of them are Calc ready. None of them placed into Calc 1. So that's the starting threshold. You kind of look at breakdown. Almost all of them have what we call high financial need, and then basic racial breakdown there. Here's the outcome data. Karen, this is useful, right? So over a period of time, we tracked 384 students finished a college degree in the STEM field, not necessarily in the college. They may have switched over to physics, okay? And there's reasons for doing that. But 384, the completion rate when you take all the students who've been part of our program is about 67%, which is more than twice percentage than if they didn't do this program. The program works because it advances them a math course, and that's in the next chart. So, 2023 cohort. I actually had data in this thing for a long time. I'm like, oh, I'm going to drown them with data. Let's keep the nice pictures up there instead of charts. But so for last year, 63%, so 29 out of 46 students increased their math placement. So we have a special carve out in the rules. When you do ESSA, you get to take the math placement exam again. Very few other students on campus are allowed to do that. And so 2/3 of them improved their math placement score by taking this program. And 71% did enough of an improvement to get out of at least one of those courses. So you went from pre-calc to calc. You went from college algebra to pre-calc. Roughly speaking, that's what I'm talking about. And remember what I said the completion rate percentages are. It's a huge impact. That's why people are getting done. And so this program works. It's just really hard to scale because it's person intensive. I have to pay housing. I'm pretty sure housing here is not free either. Housing and food are by far the highest expense. Hiring the faculty is not bad. So now let's get back to me, because I'm up here in front and I want to talk about me because I'm a professor, right? So teaching experience. This is why the challenge of this was a little bit for me. I haven't taught for a long time, right? 1998 to 2000, I taught a bunch of classes, right? Not a bunch of classes. I've never gone above one course a term. I tried to have the model I had here and make sure that I did enough research activities so the chair assigned me one course a term rather than more. Okay, fine. I taught a 100-level class. That was fun, right? The reason I did that, by the way, is you probably have faculty maybe do senior projects, mentor senior projects. Yeah, I'm terrible at that. I never showed up. The one time I did it, I assigned a student to call me to make sure I show up at the once-a-week meeting because I was terrible at remembering to do that and stuff. And actually, I cheated. You're not supposed to pick your students, and I went around and picked my students, got a really good group who could do it without my help, and then it moved on. So then the next year when they wanted to assign me, you don't want me to do that, this is bad. Why don't I do this? The provost wanted something that would be fun for first-year students. Cell phones at that time were just starting to really get out there a lot, so I taught them how it worked. And at the same time, had them map out our main buildings so I knew exactly what carrier to get from my cell phone based on what would work in those buildings. Old school RF, right? Going around there, and they basically use their phone as a signal meter. And so 300 level, right? That's the big thing where you got lots of students who have to be there because you make them go there. 400 level is the most fun. because they're seniors and you're recruiting them for grad school, either at MSU or down here or elsewhere. I have some former students here right now. And then the 800 level classes are the masters, what you call 500 level here, I think. I never got to teach what you would call 600 level. At MSU, it's 900 level. You know why? Shanker students did a rebellion. I was all signed up to teach a diffraction class. I was real excited because I get to teach a 900 level class for the first time. And Shanker students did a petition to the department to cancel that and have Shanker teach one that they wanted instead. True story. And you can see him doing it, right? Absolutely. Absolutely. By the way, the guy who did that is now at OSU, who led that whole thing. So then, but 2006 to 2020, I didn't teach at all. Yeah, a few things happened during that time. So then, during the pandemic, I told a few people it was all hands on deck, right? I mean, I don't know, well, you weren't chair at the time, but we found a number of, shall we say, more experienced faculty members decided to retire in August 2020. When we said you have to teach these classes online, and you have to teach them starting in two weeks online, more than one faculty member decided, yeah, you know, I think I'm going to retire. And I don't need that year time. I'm just going to do it now. So it was kind of an all hands on deck. So our department chair taught some, I taught some, and wow, things changed, right? 2020 was all remote. It was miserable. You're teaching these little gray boxes because we weren't allowed to have them turn on the camera. Nope, we were not allowed. The only time we could make them turn the camera on is during tests. So you're teaching to these little boxes. Not much responsiveness from little gray boxes. Now and then you had to tell someone, turn your camera off or put a shirt on. Okay, so some of the guys weren't quite what I had in mind. But 2021 was hybrid. That was a whole new thing, right? It's like you're teaching a class twice. And it feels like it. But we were getting much more facile with the tools. And then 2022 was in person. Then I stopped because the pandemic was, for all purposes, past us, and I could get back to doing the trips for fundraising. That's the real answer. During the pandemic, you couldn't travel, so you could teach. Once it was done, I was out there like yesterday asking for money from alumni. And so things have really changed. And I'm sure all the faculty in the room feel this, right? Students are much more facile with online tools. Right, the whole thing of driving things yourself, calculating things yourself, gone. They're much more able to use these tools that are out there and freely available than back in the day. Homework assignment was not evaluative. People got perfect homework scores, and then you gave them a test, and it didn't go so well. Okay, might have seen a little of that here, right? Exams by themselves are artificial best. And the question I always ask is, when's the last time your pay raise been determined on how well you do on a closed book exam that's timed? It doesn't happen. So it's a tool, but it's not the real world. The best thing are these open-ended assignments, right, where students are given fuzzy objectives and they have to go find answers, because that's the real world. And it's really good for the top 25 to 50%, right? The bottom 50% doesn't work so well, but that's it. Creativity in that can demonstrate they actually understand what they're doing. And it's very important that what didn't work is often more valuable than what did work, which is why we have labs, right? And so, okay, that's where we are. People have talked to me a lot about Gen AI. I had the fortune or misfortune to vice chair a Air Force study on this topic, and it's just a tool. Gen AI is just a tool, right? Just like slide rules were a tool. Now, by the way, does anyone in here know how to use the slide rule? Val? Yeah, there you go. Okay. That's about it, right here, right? That's the slide rule group here. When I was going through, this was the Cadillac of calculators. Yeah, there you go. There you go. The best calculator ever.
Still works.
Still works. Still works. When I was here, for some reason, the campus chose Maple over Mathematica. Adib, you remember Maple, right? Right? You could, if you knew how to, it basically was a programming language. If you knew how to do it right, it would spit back, the integral of blah, blah, blah is this. Okay, that's useful. Mathematica became a lot more commercially viable. Wolfram Alpha, everyone knows that one, right? Wolfram Alpha. Again, if you know how to type it in, it can spit the answer out very nice. I taught my daughters about that, right, as they were going through it. But now there's these AI tools, right? And I just put 3 of them up there. There's a bunch. I want to make sure I got both Google and Microsoft because we're not going to endorse any product here. They're really quite good, but they get things wrong too. And so this is very dangerous. Let's see if this works. Going to an example of Copilot, I asked it questions, right? And so the question was, what's the curl of an x-directed unit vector times a spherical wave? That's all you had to type in, right? I had to go in there like with Wolfram Alpha and figure out the notation that they're using, right? And it goes through, and if you look, it starts to going through the kind of thing you would fill out in your homework assignment, right? That's, it got to a point and said, I'm tired. Sounds like students, right? I'm tired. I'm going to go get coffee. Well, give me more details. Okay, sure. Go. And it starts going through. And if you look, it's not bad. And it goes through the whole thing, and it kind of stopped at some point. But you can go through and get answers if you tweak it enough. But it will get things wrong. I've done this on ones where it looks pretty good. I'm going to go tell someone about this. And then I go, wait a minute, it's wrong. Right? And I went back and looked, and a very simple step, it got wrong. So it will get things wrong. But the point is this is a tool. Students will be using it. People have talked a lot about not allowing them to. How are you going to stop that? I just don't see how that's possible. To the point of what we know, all typical problems can now be solved with Gen AI. Okay, I've heard this directly from faculty that all the problems that they've used for that first class can be solved with Gen AI. All of them. And it will only get better. As they find the things that are wrong, it'll get fixed, right? If you're teaching a programming course, giving them the standard assignments that I saw my daughter get in Engineering 101, what a great class you have. I love that class. I tried to get MSU to do it, and the faculty said no. Okay, but it's, I love it because it's part MATLAB and part a high-level language. You and I disagree on what's high. But the point is I thought that was a great class. But every one of those assignments, you could get Gen AI and I to do a lot of it. So the students aren't really learning that. In fact, I've been told by high school computer science teachers that the syntax of programming is pointless to teach them now because all that can be done now. And by the way, I'm not paying for that Copilot. I'm well within my free amount. I give them a little bit of money and I'll get more. Now that's another issue though, because people with families with money have an advantage. Okay, and we as a public institution need to think about that. Sometimes it does get things wrong. So what we really need to teach students is when to identify whether the answers make sense or not. And that is the biggest skill that we teach them. When a bunch of us know Gabriel Rebez, right? And I won't say who the student was, Adib, because we were here at the same time. There was a student in his antenna class. Now, if you take an antenna class, it's a very simple rule. Symmetry matters. So the gain looking end fire on a dipole should be 0. Not almost zero, it's zero, right? And then the gain this way, if it's currents like that, should be maximum, okay? And we had an assignment, CEM, where we had to write a program. And there's a student who argued with Gabby for about 5 minutes. And no, the gain on there, I calculated it very carefully, minus 300 dB. 10 to the minus 30, right? Okay, which is probably machine precision at that point. So the point is, you have to understand, no, it should be zero. I don't care what that computer thing he's doing, it's zero. Okay, so that's what we need to teach. And a lot of programming and other things will come through Gen AI. And I don't see how we're going to stop them from using GitHub, GitHub's Copilot, or any of the other tools out there, because they're there. And my argument would be, in many work functions you're going to do going forward, that's how you're going to do it. I mean, seriously, for those of us who do any programming, if there's something you can get off GitHub as a start, wouldn't you use it? Of course you would. The problem is, when students in programming classes do that, the automatic cheating detection systems flag it. Okay, again, not printed, but the cheating numbers have gone up considerably since those tools came out, because the systems flag it. Okay, but I would argue that's exactly what they're going to be doing in their internship in 6 months. So why don't we teach them the way that they're going to be using it? And so if you start thinking about what they're going to need, there's two groups. And by the way, I've carved out people who want to be lawyers. We have enough lawyers. We carved out the few people who go to med school from ECE. We need more of them, but let's just focus on two groups. Those who go for full-time employment, and those who go to grad school. Faculty in the room, how many want the top 10% to go to grad school? Right? So we focus a lot of our attention on that, okay? The truth is that's not where they go, and not necessarily what they need. Full-time employment, you have to know how to apply design rules to an open-ended problem. Okay, no one's gonna pay you to solve a problem that's solved already for the company, because hopefully they got the data that they can go back and use. It's called trade secret, okay? But you often have open-ended problems where you have to figure out a solution. But you use simple design rules that you learned, like the gain at the looking end fire on a dipole should be zero, okay? One thing that Gabby did, which I love, which I've used in my classes, is sketch the current and then sketch out what the pattern should be, just based upon looking at the current, and then see if it works out that way. Great way to do it. How to communicate is very important. When you finish with a bachelor's, you're gonna spend half your time communicating. When you finish with a master's, you'll probably spend 75% of your time communicating. PhD, 90% of your time, doing exactly what I'm doing now. So you got to learn communication skills, and our programs have gotten much better, right? Much better at that than they were. Teamwork, that's something at MSU, at least, we really pride ourselves on, because we hear from employers time and time again that we're really good at students working on teams. Less so in silos, but much better in teams. And the ability to learn outside your knowledge area, because you're going to have to be constantly adapting. Kamal and I talked about earlier, you know, your career is going to go through several changes over time. I never thought I'd have to deal with personnel issues. Yet it sucks up a lot of your time for 12 more days. And so you got to learn outside the knowledge area. Great. Grad school, it's a little different. You got a fundamental understanding in some relatively narrow area, right? You really can't drill deep broadly. Does not, and I'll show you why not in a few minutes. You need to learn how to communicate, because again, you're going to spend most of your time convincing someone your answer's right, convincing someone to invest in it, convincing somebody that you even know what you're talking about. How to build on others. The standard I have for a master's thesis or a dissertation is very simple. You should be able to hand that book to the next student, and they should be able to duplicate what you did within a reasonable amount of time, and then build on it. So when students know their dissertation's done with me, is that they met that standard. I learned that here, by the way. An ability to add knowledge in a narrow area, because that's what you're there to do. So these are very different. They look a little bit alike, but they look different. So there is a issue. I had a little fun. John Verbanker, which I hope you all vote for IEEE president, leave here and vote, was the vice president for publications for IEEE. So I asked him yesterday, how many papers did IEEE publish last year? And he found the data and showed me where to look. So I played a little bit with Excel. And so here's the number of journal papers and magazine articles per year, so 2017 to last year. That's the actual number that IEEE publishes just IEEE, but that's the big one for us, right? And then if you start to extrapolate that going forward, where it could go, right? The straight lines here to where they're publishing almost 120,000 articles a year. The high end takes you up to 180,000 a year, which won't happen. The low end, you're still here at almost 90,000 or so a year, right? So in theory, each one has something new about it, right? If not, the Office of Research Misconduct will have a little chat with you, okay? And the chair has a bad day doing that, and the associate dean for research has a bad day. So don't do that. Point is that the knowledge base is growing fast, much faster than in the past. Look at where we were in just 2017. Okay, so the knowledge in ECE is growing at a very high rate. And so if you believe in the premise that a bachelor's student should have a broad understanding across the field, and you stick at 4 years, there's only one conclusion that you can make. It has to get shallower. And eventually shallow becomes, wafer thin mint, right? And so we have a problem here, okay? And part of this is this. I looked at your curriculum and I looked at ours. In ECE, actually for EEE, I didn't do the computer engineering part, mainly because computer engineering at MSU doesn't require this class, which I teach. Therefore, it must not be a good program. And so you look at the two, laying them out, and the words are a little bit different. But you know what? They're not that much different. Okay? We use a few different words, but more or less the first year or two is kind of the same, except I really like that 101 class that you have. You may want to tell MSU at some point that they need to do that. But you kind of your first 2 years, they're pretty much the same. And then you starting to specialize more and more. What we could do is most of the focal specification happens in year 4. We could start doing that more in year 3, which again means you're making your broad-based knowledge narrower over time. You could go to 5 years. The civil engineers have been trying to do that for decades, right? Their employers came up, their accrediting groups. So if you don't know what ABET really is it's a group of professional societies, okay? So it's the American Society of Mechanical Engineers, American Society of Civil Engineering, IEEE, et cetera, and they're the ones who set the ABET standards, okay? By the way, the IEEE ones are easy compared to the rest. We got it good. Some of the rest are interesting, but I digress. The point is that they've been trying to do that for years. It's really hard because I told you that a 4-year degree in-state at either University of Michigan or Michigan State, it's going to cost your family well north of $100,000 before scholarships and all that kind of stuff, right? You add one more year. Now it's, the pressure is not to go longer, the pressure is to go shorter. We're both at 128 credits. My university has been banging on me for years to get it to 120. Because, 4 times 30 is 120, 30 divided by 2 is 15, 15 credits a term. We're all happy, right? I don't know how to do that, and at the same time in a field that's expanding at the rate ours is. And I could have the same discussion in mechanical engineering or computer science, but it's the same concept. So what do we do? Do we make it go longer? Do we make it go shallower? Faculty make those decisions. ABET says what they have to learn, not how to do it. But it's the faculty who have to, in the end, decide how we're going to meet that need. So where do students go? I looked at both our programs. Based on your college data, 59% do full-time employment when they leave this campus, and 32% go to grad school. A lot of them stay here, by the way. They really like A squared. I don't know why. Okay? And then there's a few percentage who are still finding themselves. Okay? At MSU, full-time is 79%. Grad school, 14. Distinct differences in where people go. I looked at Western Michigan because I could find it easy. I tried to use the colors that they use for the Broncos. They're about the same as MSU. And I'm betting if I went to the other public schools in Michigan, they're going to be more or less the same as the one on the right. So in some sense, you're growing a large quantity of future grad students. The rest of us are growing a large quantity of full-time. So is it time to start thinking differently about all students doing all the same thing? Here's the student numbers. This is useful, Jeff, at least for a few more months for you. I've looked at ASCE data. We all report our data. I've dug into this and on something Eric and I have been working on for a while. Sliced it, diced it, did a lot of different things. This is the EE and CPE students for 2022 ASCE data and where they're at as reported by each university. So I'm trusting that they followed the rules. Okay, ASCE is pretty strict on that because of things that people did over the past, like put the construction budget into the research expenditure line. We're not allowed to do that anymore. And if you don't know who did that, I can tell you. So the person was here at one time. Let me put it that way. So the largest programs are in East Lansing. That, by the way, is driven largely by the way the admission process works. Okay. Mechanical engineering and computer science have a higher threshold than EE and computer and engineering. That is a fact. Okay. And it's based on the capacity. The largest department per student is EE. Is ECE. I don't know how that happened. And so if you take Michigan State, University of Michigan, and Tech, 52% of all the ECE students are at those schools. This is bachelor's. You have by far the most grad students. I'd throw a coin in the air and say in ECE, if you take all your grad students, it's equal to the sum total of the rest. Probably a fair statement, but I didn't check that out directly. But my point is this is where the students are, this is where the future employees are going to be, this is where the grad students are going to come from in Michigan. Okay? So we need to increase the supply set of EEs. It could be computer engineers too. But I am a little biased because the EEs have to take the fields class and the computer engineers don't. So here's my proposal to think about. In a master's program, we have plan A and plan B. We've had plan A and plan B forever. Plan A is largely meant to push you towards a PhD. And plan B is meant to be an exit. So my question is, should we start thinking that way at the bachelor's level? Plan A and plan B. I don't know. It's just, I'm trying to put something out as part of this talk to think about that, traditional students focus on solving methods and open design challenges, put more lab time and projects in there. Remember that Tech-Eng program that we just started. Less mathematical manipulation. Let Gen AI, they're going to be doing that anyway, okay? Mandatory internships and co-ops. You should have work experience as part of your bachelor's because that's what's going to drive you towards Ford and GM and wherever, okay? For those who are going to go on to grad school, and at MSU, it's probable they're an honors college student because of the way this system works. We have a thing called the Professorial Assistance Program. First year and second year students get paid to do research in your labs. It's completely designed to get you to go to grad school. There's no purpose in doing it other than to encourage you to go to grad school. So there are going to be students who are pointed towards grad school. So why don't we focus on a deep understanding of those design rules in those honors classes, different sections, right? Let's give them deep experience in manipulating the mathematics necessary to understand some of the more complex concepts that we're trying to push in grad school. And mandatory research experiences, preferably paid, by the way. I don't believe an engineer should do anything for free, ever. Preferably paid, right? I'm going to make that point. But this is the kind of thing that prepares you to succeed here at Michigan in grad school. This is the thing that's going to prepare you to succeed at GM. So it's happening by default anyway. Let's do it by design. So that's the challenge I put out there. It's kind of like the end of the seminar is maybe it's time to rethink the one size fits all. I'll bet that curriculum at Michigan and Michigan State hasn't been touched in 20 years. I'll bet if you go look at the dates that they were revised, it's when the capstone requirement was put in, and that was the last time it was touched. But think about all the changes that happened in 20 years. Shouldn't we rethink the way we teach students so we can grow the economy here in Michigan? And when the economy grows, that means tax dollars are paid, which means professors can get paid more because professors need Porsches too. Professors need Porsches too, right? That's very important. So in the end, there's the mandatory questions.